This is the first pencast for section 2.6, 2.6.1, the derivative of natural log of x. So before you watch this video, you should stop and review inverse functions. You can either look at the Khan Academy video, you can read the book, you should really do both of those things. So the one thing I will remind you about general inverse functions is they have the property, or this is how they're defined, is that they satisfy the cancellation equations. So two functions, f and f inverse, are said to be inverse functions if when we compose them with each other, they undo each other. So in other words, if f of f inverse, and that's how we say f to the negative 1, we mean f inverse, not 1 over f in general. So if f of f inverse equals x for all x in the domain of f inverse, and f inverse of f of x equals x for all x in the domain of f. That's what it means for two functions to be inverses of each other. So let's talk about the natural logarithm. The natural log, which we denote ln of x, that is defined to be the inverse of the function e to the x. That's where the natural log comes from. By definition, it is the inverse of e to the x. So one way to write this is we say natural log of y equals x is the same as solving the equation e to the x equals y. So you can see here that natural log and e to the x, they undo each other, those two functions. So this is the definition of the natural log. And remember what the domain and the range of e to the x is. The domain is all real numbers, so the interval from negative infinity to infinity, and the range is all positive numbers, so the open interval from 0 to infinity. Now, when we take the inverse, the role of x and y switch. So the domain of the natural log is the same as the range of e to the x, so it's from 0 to infinity. And the range of natural log is the same as the domain of e to the x, which is negative infinity to infinity. And we have this relationship between inverse functions in general. Inverse functions are reflections of each other about the line y equals x. So there's the graph of y equals e to the x, which we know, and we just flip that over the line y equals x, and we get the graph of y equals natural log of x. So notice e to the x has a horizontal asymptote at y equals 0. That causes a vertical asymptote for the graph of natural log of x at x equals 0. Okay, so we can use the cancellation equation to find a formula for the derivative of the natural log of x, and here's how we'll do it. We will use the fact that e to the natural log of x equals x. And this is going to be our general strategy for deriving formulas for derivatives of inverses here. So the same sort of principle is going to work. So we write down the cancellation equation, and we put the function for which we are interested in finding the derivative of, we put that in the inside. Okay, so notice we've put natural log inside the exponential function. Then I'm going to take the derivative of both sides. So the left-hand side, I'm just going to leave that as is for a minute, write it as the derivative of e to the natural log of x. But on the left-hand side, or on the right-hand side, notice what happens. I get dx dx, which is just 1. Derivative of x with respect to x is just 1. Now, on the left-hand side, I can use the chain rule. So I take the derivative of the outside, leave the inside alone, so e to the natural log of x, times the derivative of the inside, which is what I'm trying to solve for, so I just write it, I don't know what it is yet, I just write that as d dx of natural log of x, and that equals 1. Now I use the fact that e to the natural log of x is just x, so I have x times the derivative of natural log equals 1, and now I can solve this equation for the derivative of the natural log of x. I just divide both sides by x, and I get that the derivative of the natural log of x is 1 over x. And notice that this is defined on the interval from from 0 to infinity, which makes sense because that's where our function was defined as well. So we don't expect the domain of the derivative to be any bigger, and in fact, it's not any smaller either, because the only bad thing we could do to 1 over x is divide by 0.